we talked about on Tuesday, because it's been a day since we talked about this, it was simplifying rational expressions. And we make sure that they're simplified. We know they're simplified if there's nothing in common on top and bottom other than 1 or -1. As long as the only thing left in common is +1 or -1, then it is simplified. We can't reduce it any further. And this here is the last one that we did, or the one before it, x minus 4 over x squared minus 16, or x plus 4 over x squared minus 16 is the one we finished on Tuesday. So we look at this here, x squared minus 2x minus 3 over x squared minus x minus 6. We need to simplify it as far as possible. Now, as tempting as it is to say that we can cross out the x squared and x squared, we cannot actually do that because the x squared, the 2x and 3, since they're being subtracted, we have addition, subtraction between them, they're stuck together. It is one term. So we can't just cross it out like we can with multiplication. So what we're going to have to do is we're going to have to factor the top and bottom of this fraction. Now, it doesn't matter which one we factor first, but I would pick one and go from there, because once we get the factors of one of them, it should give us a hint at what the factors of the other could be. Do we want to factor the numerator, the top, or the denominator, the bottom of this fraction first? Because it doesn't really matter. Which one do we want to try first? Do first. The bottom. Now, the first thing we always look for is a greatest common factor. So x squared, x, and 6, there is no number or term in common with all three. So we can't factor that out. But the third term is negative. And since the third term is negative, we know the signs are going to be opposite. One is going to be positive, and one is going to be negative. They have to be opposite signs. Now we're going to find the factors of the first and third terms. Well, our factors of x squared, there's only one set, x and x. That's the only set of factors we have for that there. Now the factors of 6, there's a few. We have 1 and 6 or 2 and 3. Which one of those two do we want to try first? 2 and 3. So we can plug in the 2 and 3. And then off to the side, we can check and make sure this is the correct setup. X times -3 is -3x. 2 times x is positive 2x. And -3x plus 2x gives us -x, which is the middle term we wanted, telling us that x plus 2 times x minus 3 are the correct factors. Questions on how we factored this here? Questions on any of this so far? Now what we need to do is factor the top. We need to factor the numerator. And again, the first thing I would look for is a greatest common factor if there's something in common with all three terms. Because if there is, we're going to factor it out and then go through our factoring steps. At x squared, 2x, and 3, there is no greatest common factor. There's nothing in common with all three. So we can move on to our factoring steps, our two sets of parentheses with 3 spaces. Now, since the third term is negative, our signs have to be opposite. One's going to be positive, one is going to be negative. Factors of x squared are x and x. Factors of 3 are 1 and 3, yes? Are there any other sets of factors for it? No. Now, we also know if this is going to simplify, we need something to be in common on top and bottom, yes? So could I put the 3 here and the 1 here, then have something simplify? Because giving this here, we have x plus 3 times x minus 1 on top, yes? On bottom, we have what? X plus 2 times x minus 3. So if this was the correct setup, is there anything in common on top and bottom? No. So there wouldn't be anything that we could reduce. We couldn't simplify it any further. This would be the answer, if that's the correct setup. Does that make sense? So this could be it, but this would not be my first choice. Because if we're going to simplify, if we wanted to reduce, we need to have something in common on top and bottom, yes? Well, wait, with the 3, if I put it with the minus, I do get x minus 3, yes? Which means I do have something in common on top and bottom. So something will reduce if I put it this way. Now, does that guarantee that this is the correct setup? No. But it gives me a better chance at having something simplify. So we can still check it. X times negative 3 is negative 3x. X times 1, or 1 times x, is positive 1x. Negative 3x plus x, negative 3 plus 1 gives us negative 2x. Is that the middle term we wanted? Yes. So that tells us that is the correct setup, which also means we have what in common on top and bottom? The x minus 3, which means these will simplify out. They will reduce to 1 on top and bottom, leaving us with now it doesn't simplify any further. No greatest common factor in either set of parentheses. And since they are being added together, the x and 1, the x and 2, they're stuck together. This is as far as it goes. We can't do anything else to it. Which is also telling us that x squared minus 2x minus 3 all over x squared minus x minus 6 is equivalent to x plus 1 over x plus 2. I haven't taken the time to go through every questions on the ACT y'all took yesterday, but I think y'all saw something similar to one of these here that we've been doing. They phrased it as, I think it was a of x equals this expression, b of x equals this expression. Which of the following is equivalent to a over b? Really, all they were saying, the a was the top, b was the bottom. Simplify. Now, for the most part, we're getting into that, we're covering it, yes? And one thing I want to emphasize, especially on the ACT, if they say equivalent, the same, which of the following expression is the same or equivalent, it means they have to be equal, yes? That means for any given value of x that we could have plugged in for the start, we would get a number, yes? If I replaced x with, say, 2, that would give me a value for my top expression, yes? And if they were to be equal, and I plug that same value of 2 in x for answers A, B, C, and D, one of those should have the same exact value as the starting expression, yes? So whichever one does is the correct answer. The ones that don't are wrong. Does that make sense? So again, I'm trying to emphasize this so that we see kind of how to take the ACT and multiple choice test. That's also why I don't like multiple choice tests, because at that point, did we actually have to know how to simplify this rational expression? No, I substitute a value in. Doesn't matter the value. I could have done 2, 3, 4, 7, 9, and as long as they're the same, it still works. So, questions on this one here? Restrictions. Restrictions are just our values of x that would make the denominator be 0. So here, for 2 places, we'd have a denominator of 0, division of 0 is x plus 2 and x minus 3. So with our x plus 2, to see what value of x would make this be 0, we just need to get x by itself. And to do that, we're going to what? Do from both sides. Our positive 2 minus 2 would be 0, leaving x by itself, telling us that if x is equal to negative 2, we have a division of 0. It does not work. We can do the same thing for x minus 3, but instead of subtracting 2 from both sides, we're going to we're going to add 3. Those would cancel, telling us x is equal to 3. So if x is 3, we have a division of 0. So 3 cannot work. So we feel good about finding those there, yes? That also means with the method I was talking about with simplifying earlier, if I chose 3 as the number to check, it's going to throw up an error. Because the denominator would be 0. And especially if you're using that on something like this here, you plug it in for the first one, it will tell you domain error or division of 0 error. Pick a different number and try it again. In most evaluating ones, a number to avoid for the most part, it doesn't work every time. Most of the time, 0 is great, but sometimes it doesn't help us much. Especially if you're checking properties of exponents, stuff being multiplied together, 0 doesn't help us. Because no matter what I multiply 0 by, it's going to be what? 0. What's the other number that doesn't help us when trying to figure out multiplication stuff? 1. Because no matter how many times I multiply 1 by itself, it's still 1. So those don't help us. Here, 0 would be great. 0 is not a restriction. And if we plug 0 in here, what's all that going to be? 0, because 0 squared minus 2 times 0, that's 0. All of this would be, so really it'd just be negative 3 over negative 6, which is 1/2, yes? If this is an answer choice, and I plug 0 in, well, 0 plus 1 is 1, yes? 0 plus 2 is, it's the exact same thing, so they are the equivalent expressions. And I will say this also works on problems that especially need to pay attention to what they're asking when it says which of the following is not an equivalent expression. We're looking for which one does not have the same value. They like to throw those in sometimes. And we will start going through some of those in here so we kind of see what it's asking, what it's doing, because some of the ones I saw, the wording was. And we'll look at some more of those as we go through, because I think y'all all remember the triangle between these 2 points. It gave you an angle, 2 sides, find the length of the missing side. And then at the bottom, it told you that angles A, B, and C are represented by this. And B squared is equal to A squared plus C squared minus 2AC cosine of B. Kind of thing. It threw that at the bottom of it. I did that one earlier today. I started plugging this in and using this. You didn't even need it. The angle that they gave you is 90 degrees, which means it's a right triangle. If we want to solve for the missing side of a right triangle, we have what? A squared plus B squared equals C squared. It was a Pythagorean triple, or Pythagorean. We just solved it that way. But again, they gave you the law of cosines to see, is that going to distract you? Which I think is dumb. Because that's not so much a test of what you know how to solve a triangle, but can you understand that this equation is not necessary? I don't think that's fair. So we'll start going over some of those, looking into them so that y'all can see how to look at the question. Because I will say it time and time again, the ACT is more of a test of how to take a test, how well you can take a test, than as much as what you actually know. So, multiplying rational expressions is what we're looking at next. When we multiply 2 fractions together, we multiply numerator by numerator, denominator by denominator. We multiply together, top to top, bottom to bottom. Now, multiplying these 2 here, these monomial just are single term on top and bottom. Together, there is multiple ways to do this. I'm going to show you at least 2. And I have a feeling method 2 you're going to like better than method 1. So Method 1. The first method, what we're going to do is we're going to multiply these together. Top to top, bottom to bottom. Now, I'm going to multiply them. I'm not necessarily going to multiply the numbers and terms together. We're just going to rewrite them so like terms are next to each other. So for multiplying the top, we are going to have to multiply the 8 and 7, yes? We also have x to the third times x to the fourth. And then we have y times y cubed. Because again, we multiply straight across. And the nice thing with multiplication, order does not matter. If we multiply 8 times 7, 7 times 8, we still get the same number. X to the third times x to the fourth, y times y cubed, same amount. On bottom, we'll have 2 times 4 times x. Any other x terms? Then we have y squared times y. And I'm not saying method 1 is bad. I'm not saying that there's anything wrong with method 1. If you like it, if you see how it works, do it that way. Because one of the things they say for this here, I'm not going to do it for every term, is that we break it up into the prime factorization. We break it up into their products. So 8, it would be 2 times 2 times 2. I'm just going to say 8. 7 is just 7, because 7 is prime. X to the third, how many x's do we have there? 3, yes? So that's the same as saying what? X times x, yes? We have x to the fourth, which means I have, I'm going to switch over, 1, 2, 3, 4. Then we have our y term here, and we just have one of them. And then y to the third, we have 1, 2, 3. So method 1 is just we break it up into as simplest terms as possible on top. And we're going to do the exact same thing on bottom. Because we'd have 2 for 2, because that's prime. 4 would be 2 times 2, and go from there. Now our x, we just have one of them, yes? Our y squared, I have 2 of them. And then we just have one more, yes? Now, it seems odd we're writing it this way because I'm splitting it all the way out so we have our factors. Okay? We're going to look at the variables. Well, how many x's do I have on bottom? 1. Yes? So one of these will simplify with one of those because I can move them out to the side. We have x over x. That simplifies to 1. Yes? We're good with that there. Well, with the y, this first y, we'll simplify with one of those y's, yes? The second y on bottom, we'll simplify with the second one of the y's on top. And then our third y on bottom, we'll simplify with one of the y's on top. So it's literally break it out into the simplest form. In terms on top and bottom, we just cross out, we cancel out. So we get it with the variables, yes? Now it seems odd. Why didn't I do it with the numbers? Well, you have calculators, yes? Can a variable get plugged into a calculator? Yes. Would it actually give us what the variable is? No, it has to have a number, yes? So on top we have 8 times 7 over 2 times 4. That's a 7. It'll do those. Well, on bottom we have 2 times 4, and what is 2 times 4? 8. The 8 on top and bottom would cancel, leaving us with 7. So really, we know that those are gone and that's gone. So let's see what's left. On top, we have the 7, yes? We have x to the 1, 2, 3, 4, 5, 6, And I do have y to the first, yes? Is there anything left on bottom? Well, yes and no. No, there's nothing written, so it's been reduced to 1. We don't have to write the 1. So the final answer is 7x to the 6th y. Okay? We get method 1, yes? Would we all agree that method 1 is tedious? It's writing out a whole lot. Let's look at method 2, another method for this. Method 2. So we've done fractions, we've done multiplying terms, like terms up to this point. Because when we multiply these two together, I'm going to still do the same thing. If rewriting it helps, rewrite it. We have 8 times 7 times x to the 3rd times x to the 4th times y cubed. 2 times 4 times x times y squared times y. And yes, first step, either method, we get to the same spot. We don't necessarily have to do this spot. And you'll see it here in a second because we're going to multiply. Just like method 1, if I want to plug in the calculator 8 times 7 over 2 times 4, like we did and have it reduce it for us, we still can do that. So here I know that 8 times 7 is 56. On bottom, 2 times 4 is 8. 56 over 8 is still going to reduce to 7. With our variables, whenever we multiply like bases, we add the exponents. So x to the 4th times x to the 3rd gives us x with 4 plus 3, which tells us this is x to the 7th, yes? Our y is on top. We have y times y to the 3rd. 1 plus 3 is. On bottom, we only have one x, so we still just have x to the 1st. Y squared times y. 2 plus 1 is. So you're telling us we have y cubed. Now, yes, we could have jumped straight from the start to this here. 8 times 7, multiplying those like terms together. Well, now we just need to simplify this here. As we already said, 56 over 8 is 7, yes? When we divide like bases, we subtract the exponents. So a to the b over a to the c, by definition, is equal to a to the b minus c. We move it to the top, subtract the exponents. That is, by definition, that is the theorem. That's how we divide like bases. The way I like to think of it is, so we look at x to the 7 and x on bottom, yes? So my exponents are 7 and 1, yes? I just subtract them, regardless of sign. So if the 7 had been on bottom, I'm still going to do 7 minus 1. Because 7 minus 1 is 6. So the big thing I focus on from there is the exponent bigger on top or bottom. If it's bigger on top, it's going to stay on top. If it's bigger on bottom, it's going to stay on the bottom because that's where the most of them are. So we're only removing 1. 7 minus 1 is 6. And since we had more, the bigger exponent on top, it's going to stay on top of the fraction. Does that make sense? For this one here, it wouldn't have made a difference because we would have said x to the 7 minus 1. 7 minus 1 is 6. X to the 6 is on top. If the 7 had been on bottom, if we wrote it in this way, if we had x over x to the 7th, it'd be x to the 1 minus 7. Oh wait, that's x to the negative 6. To make the exponent positive, we've got to move it from the top of the fraction back to the bottom. That's what I mean by if it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. Because if it's bigger on bottom, we would get a negative exponent from this and go from there. If you want to put that this is a side note, I would definitely put it because it's not pertaining to this problem. Lastly, we have y's. We have y to the fourth over y to the third, yes? 4 minus 3 is 1. Is it bigger on top or bottom? Top, yes? So y to the first will stay on top. And since everything out of the bottom of the fraction reduced, it's simplified out, we're left with this here. We like method 2 or 1 better? 2. It is the exact same process, it's just we've condensed a lot of the steps down. We're going to find the product of these here. 6x squared y over 3x y cubed times 9x to the fifth y squared over 2y. So we can multiply these together. We're going to be multiplying the 6 and 9. We're going to be multiplying our x squared and x to the fifth. We're going to be multiplying our y and y squared. I'm just rearranging them so they're next to each other. If this step helps in keeping the like terms, keeping those terms together, monomial with monomial, do that. On bottom, we have our 3 and 2. So we'll have 3 times 2. We still have 1x. And we're going to multiply y to the third times y. We're going to be multiplying these together. And then we can simplify. Now again, when we simplify, the order in which we're simplifying, especially since these are one term, yes? On top, the 6, 9, x squared, x to the fifth, y, y squared. All of these are being what? Multiplied. So how I simplify doesn't matter. Because of multiplication, we can rearrange it, reorder it. That's what method 1 was doing. So that I get like term over like term, they simplify to 1. Yes? So is there anything telling me at this point of noticing on bottom that we have 3 times 2, yes? Well, 3 times 2 is what? 6, yes? So is there anything saying I can't go there? No, because multiplication on top and bottom order doesn't matter. Really, I just said I'm going to move the 6 over to its own fraction on top, 2 and 3 on bottom. That's 1, that's gone. We kind of see that? Oh, wait a minute. Y over y can also cancel out, yes? We have 2 of them here, 1 of them here. We can start doing that. That's simplifying part by part, part by part. There's nothing wrong with it. There's nothing saying that we can't do that. But if you notice, this is a lot of stuff to try to keep track of in our head, yes? If that starts getting a little messy and a little over the top, don't do it. Because we can still come here and say 6 times 9 is 54. X squared times x to the fifth. When we multiply like bases, we add the exponents. So that would be x to the 2 plus 5, so x to the 7. Y times y squared would be y to the third. On bottom, 3 times 2 is 6. We still have our 1x, because there's no other x's on bottom. But x to the third, or y to the third times y would be y to the fourth. Yes? Now we can simplify from here. We can finish simplifying this here. 54 over 6 is going to be 9, and it's on top. Yes? And again, I'm going to try to keep referring back to the ACT, because we know 9's on top. We could have done that from the beginning. Yes? That means every answer choice that does not have 9 in the numerator is out. That's going to help us get there. Then we can look at x's. x to the 7 over x to the first. When we divide like bases, we subtract the exponents. 7 minus 1 is 6. It's bigger on top or bottom? Top. So it's going to stay on top, yes? Now the only other thing left we have is y. We have y to the third over y to the fourth, yes? 4 minus 3. 1. Is it bigger on top or bottom? Bottom, so it's going to stay on bottom. We didn't do the restrictions on the last one, but really we just say x and y cannot be 0. Since they're being multiplied together, we'd set them equal to 0. They're just not 0. Questions on this here? And the main reason these works, they're monomial and monomial. We're just multiplying them together and going. And yes, if we were trying to solve this and we got stuck, I can pick a value for x and y. I'd pick something different. I wouldn't pick x as 2 and y as 2. We can pick x as 2 and y as 3. Plug them in for x and y and see which one has the same value. Equivalent. Same.
Just a reminder, there will be an STA meeting during lunch today in Coach Coffey's room. Thank you.
So, let's look at this one here. 3x to the fifth y squared over 8xy times 6xy squared over 9x cubed y. So we're going to multiply these together, yes? And again, we can start the exact same way we've been doing. 3 times 6 over 8 times 9. Multiply the numbers together. So we'd have 3 times 6 on top. Well, what is 3 times 6? 18. Our next thing we would have is x to the fifth and our x. X to the fifth times x. We add the exponents, which gives us x to the 6. Y squared times y squared would be y to the fourth. On bottom, we have our 8 times 9. And 8 times 9 we know is 72. Then we'd have our x times x cubed, which would be x to the fourth. And lastly, y times y is y squared. So again, multiple choice. 18 over 72, probably need to get a calculator to figure that one out, yes? But whatever it is, most likely the number on top is going to be smaller than the one on bottom. I mean, we divide two numbers, 18, a smaller number over a bigger number. It should still reduce the smaller number over a bigger number. We shouldn't magically get the numerator bigger than the denominator, the top bigger than the bottom. It's just not going to magically turn into 9/4. I'm going to be impressed with myself if that actually reduces to 4/9. Because I have not checked that. I just picked two numbers. So that kind of helps us know the answer choices. Gives us an idea of what they can't be. X to the 6 over x to the fourth is bigger on top, so they should be on top. X to the 6 over x to the fourth, 6 minus 4 is 2. Since it's bigger on top, it stays on top. Y to the fourth over y squared, 4 minus 2 is 2. So it stays on top. So we know we should have a bigger number on bottom, x squared, y squared on top, yes? Most likely, especially with 4 answer choices, that's either going to eliminate it down to 2 or 1. 18 over 72. 1/4. So 1 on top, 4 on bottom. So x squared, y squared all over 4. Questions on this here? And we would say that the restriction is x and y both cannot be 0. This is the last one we're going to look at today. We're not going to be able to finish the note sheet today, and that's fine. We'll finish this up on Friday. It'll be a good place to finish. Also, if we have time, I'll pull some of the questions from the ACT to look at. If you all have specific ones you want me to look at with you, let me know. We'll pull those. I will pull those so we can see them and kind of break them down and see how to look at them. Because sometimes being able to interpret or read the problem is just as important as being able to actually solve the problem. Now, when we multiply these together, we could multiply through. I would not suggest it. I would not advise it. Because, and what I mean by that is, well, we're going to multiply the 3x by the x squared x and negative 20. Again, would not advise that because that's just going to make everything bigger, yes? If we have them factored, when we multiply two sets of parentheses together, we just really put them right next to each other. So if we look at the tops and bottoms of these here, the 3x on bottom of the second expression is, well, 3x. It is one term. No way we can factor it. It's just a single term. The other one I would look at is the 3x minus 3x squared. There is a greatest common factor between these two terms. 3 and x, yes? Now, we'll factor this here, but one of the big things, and we'll see it as we go to tomorrow and further, we want the term with the biggest power, we want the variable x with the biggest exponent to try to be positive, and we'll see why here in a second. Now, if I factor 3x out of 3x, we get 1, because it simplifies out completely, minus. When I factor 3x out of 3x squared, the 3 factors out completely. The x squared is going to become x, giving us 1 minus x. Now we're going to factor on bottom here. X squared plus 4x minus 5. No greatest common factor between the 3 terms. If there is, we want to factor it out. It's going to make it nicer to work with. However, there's not one, so we'll move on to our 2 sets of parentheses with 3 spaces. And then we're going to find the sign. Since the third term is negative, the signs are opposite. One's going to be positive, one's going to be negative. Now the factors of x squared, only one set. We have x and x. Factors of 5 are 1 and 5, yes? Only one set, so we got to plug it in. The middle term is positive, so we'd probably want bigger factors positive. Not always the case, but we can try 5 and 1. And if we check this here off to the side, x times negative 1 is negative x. 5 times x is positive 5x. Negative x plus 5x is going to be positive 4x. All right. And lastly, x squared plus x minus 20. Third term, there is no greatest common factor between these. Third term's negative, so the signs are opposite, plus and minus. The only factors of x squared are x and x. Now we have 1 and 20, 2 and 10, 4 and 5. I'm going to go on and give those to you. Now we need to figure out which set of factors we want for 20. 4 and 5. Because if we have 4 and 5, there's a good chance we have something common on the bottom. Specifically, x plus 5. Because even though they're on different parentheses, they are going to multiply together to become 1, and we'd have them on top and bottom. And if I check this here, x times negative 4 is negative 4x. Positive 5 times x is positive 5x. And negative 4x plus 5x is positive x. Questions on how we got to this point here? Now we multiply two fractions. We multiply the top with top, bottom with bottom, yes? So we try to move our monomial terms, the terms not inside parentheses, to the front. Because if I multiply 3x times r1 minus x times x plus 5 times x plus 4, well, with parentheses, to show that these are being multiplied together, all we have to do is write them next to each other. Because two parentheses next to each other is understood to be a product multiplied. So really what we did is just what? Squish the tops all onto the same line next to each other, yes? On bottom, we'll do the same thing, but again, anytime we have these monomial terms, these terms without plus, minus, whatnot, these greatest common factor kind of terms, we want to put them out front. Just so we can keep track of them so they don't get lost in the mix of being awkwardly wedged between x minus 1 and x plus 5 or at the back. We put them to the front. I'm going to stop here. I hate stopping here, but I'm going to stop here because we have a minute. I could push through and get to the final part. If you have a chance to look at it, see if you can factor it down, because there are two sets of parentheses that are in common on top and bottom.